Welcome all. Today we will look into the projection of line inclined to both HP and VP. Today we can discuss some problems related to the category line inclined to both HP and VP. Here is a problem. Line AB is 75 mm long. Its front view and top view measures 50 mm and 60 mm long, 50 mm and 60 mm long respectively. End A is 10 mm above HP and 15 mm in front of VP. Draw projections of line AB if end B is in first quadrant. Find angle with HP and VP. Here we have to find out the true inclination with HP theta, true inclination with HP theta, and true inclination with VP phi. We have to find out true inclination with HP theta and true inclination with VP phi. Here, the given data says that end A is 10 mm above HP and 15 mm in front of VP. And this is the step-by-step procedure in which first we have to draw the XY line, and then we have to draw one end projector. Here we can locate the end A. End A is 10 mm above HP and 15 mm in front of VP. 10 mm above HP and 15 mm in front of VP means that point lying in first quadrant. Then we can represent the 10 mm above HP means that 10 mm above XY line, and 15 mm in front of VP means we can represent that 15 mm below XY line, like this. Then we can plot that point A dash, front view of end point A and top view A. Then we can draw the locus of that A dash and A. Then here we have already given the front view, length of front view as 50 mm. Length of front view as 50 mm and length of top view as 60 mm. We know that by utilizing the 10 parameters, already we have discussed that 10 parameters and the circuit diagram, we know that we can represent the true length in elevation which is inclined theta degree with XY line in front view. Then we will get a shortened length. Like this. Here when we provide that inclination with HP like this, then we will get a shortened length like this. Here this point is A dash and this point is B1 dash. Then this particular point, this length will become the top view. That length will become the top view. This length will become the top view. Then we can represent the length of top view. 60 mm here. We can represent that 60 mm here. Like this, we can represent that 60 mm as A dash 1 dash. That length is equal to 60 mm. Length of top view. And we can represent the length of front view. Here. In top view. Length of front view here. Then that this length is equal to 50 mm and this length is equal to 60 mm. Then if this particular length is given, then we can project that length like this, and we can find out that point B1 dash. For that purpose, from 1 dash, draw a vertical line upwards, and from A dash, taking true length 75 mm in compass, mark B1 dash. Here we know that this particular point is 1 dash. Then if we project that point 1 dash and draw an arc with radius a dash b1 dash is equal to true length. Here that true length is equal to 75 mm. So that we can find out the point, or we can look at the point b1 dash like this. That point will become b1 dash. Then immediately we can represent the locus of endpoint B, locus of endpoint B, and then we can represent the front view. Here that front view, length of front view is already given as 50 mm. Then we can draw an arc like this and locate B dash. Then we can locate that locus, then we can draw the front view and locate B dash. Locate B dash. Here in the next step, we can repeat the same procedure in top view also. In top view also. In the next step, we can repeat the same procedure in plan also. Then we can project that point to downward direction, and we can draw an arc with radius true length, and we can easily locate B2. Easily locate B2. Then we can draw the locus of endpoint B in plan also. Then we can draw the top view like this. Here we have already given that length as 60 mm. We can draw an arc with radius 60 mm and the center A. Then we can locate that point B. That point B. Then for counter checking this particular answer, we can draw an end projector passing through B dash, which is perpendicular to XY line. If that line is passing through this point B, then the answer will become completely correct. We can counter check that process also. We can counter check that process also. Here we can project that point 2 up to this particular locus. Then we can rotate A dash 2 dash, which is parallel to XY line, and we can check whether that arc will passing through point B dash or not. If it is passing through B dash, then that process is correct. Then we can find out the angle theta. Angle theta is the true inclination with HP, which is the angle between true length in elevation and XY line. This angle, and here this angle is equal to phi, true inclination with VP. That is the angle between true length in plan and XY line, phi. We can look at theta and phi. This is all about problem 4. Problem 5. Top view of a 75 mm long line CD measures 50 mm. End C is in HP and 50 mm in front of VP. End D is 15 mm in front of VP and is above HP. Draw projections of CD and find angles with HP and VP. Here again, we can find out theta and phi respectively. Theta and phi respectively. Here end D is 15 mm in front of VP and is above HP. That means that particular point D is lying in first quadrant. But the distance from VP is given. Distance from HP is not given. But in the case of end C, that distance from HP is given as 0. That means that end point is in HP. That means the distance from HP is equal to 0. And 50 mm in front of VP. That means the distance from VP is equal to 50 mm. Here, again, this is the step-by-step procedure. We can draw the XY line first, XY line. Then we can draw the end projector. Then we can locate point C like this. Here that end C is in HP and in front of VP. That means either in first quadrant or fourth quadrant or in between first and fourth. Then if a particular point is in HP, then its front view must be on XY line. Front view C dash must be on XY line. Then 50 mm in front of VP means that we can represent that 50 mm below XY line and locate point C. This is the procedure to locate point C. Then we can draw locate C dash on XY and C 50 mm below XY line. We have already discussed that part. Draw the locus of these points. We can draw the locus of these points. Locus of end point, locus of this C dash is on XY line itself, and locus of C is drawn like this. Then we can draw the locus of end point D. Here end D is 15 mm in front of VP. 15 mm in front of VP means we can draw the locus of top view of D like this. Here this length is equal to 15 mm. 15 mm from VP. We can draw that dimension. We can mark that dimension in HP. That means below XY line. Below XY line, because this point is in first quadrant. HP below, VP above. First quadrant. That end point D is in first quadrant. Okay. Then this is the locus of the top view of end point D. End point D. Then we can draw true length in top view and the length of top view. Both are we can represent both views, both lines. Here this is the first procedure. Top view, we can represent the top view like this, because the length of top view is already given as 50 mm. Then we can represent the top view of the line like this, CD. We can draw an arc with radius is equal to 50 mm and center is equal to C. Then we can locate end point C, end point D at this particular point. Then we can represent the true length in plan also like this. True length in plan also like this. That point is D2. C D2 is the true length in plan. True length in plan. Then if this plan is in true length, then its elevation must be in true length. That is the concept. Then its elevation must be parallel to XY line. If plan is in true length, then its elevation must be parallel to XY line. Then here that elevation is already on XY line. In order to make that elevation parallel to XY line, we have to project that D2 up to this XY line, XY line like this. Then we can locate that D2 dash. Then we made that front view parallel to XY line, or front view is in XY line or parallel to XY line. Then automatically that top view must be in true length. Then we can rotate this point D2 dash in such a way that the radius of the arc is equal to C dash D2 dash and center is equal to C dash like this. Here in this arc we can locate a point D dash. But we didn't have the locus of this end point D in elevation, because this distance, that above HP distance is not given. But we know that the end projector which is passing through point D must passing through D dash also. That is the concept. Then we can locate D dash in such a way that we can project a line which is passing through D and find out the intersecting point of that line with this particular arc. Then we can locate D dash. Then we can draw the front view like this, C dash D dash, and we can draw the locus of D dash and D1 dash like this. Then in the next step we have already done the orthographic projection, and then we have to find out theta and phi. Theta is the angle between true length in elevation and xy line, and phi is the angle between true length in plan and xy line. That is already found out. True length in plan and xy line is equal to this one. This angle is equal to phi. This angle is equal to phi. We can find out that angle. Then if we draw the true length in elevation, then we can easily find out theta also, like this. We can find out that theta, and we can find out that phi here, theta here. Theta is the angle between true length in elevation and xy line. Okay, then the problem is completely solved. Thank you. Thank you all.